Welcome everyone to Design Control Introduction. This is a Lunch with Larry series where we're going to talk about how to do design control, the different frameworks, how those different frameworks relate to requirements management. Quick slide about me. If you want to get a hold of me, talk to me about some of these issues, some of the pros and cons of different ways to deploy things. This is my contact information. Have a design control registration link if you want to send that to anybody, but also the Lunch with Larry YouTube channel. Subscribe to that and we'll get to streaming these on YouTube if I can get enough people to subscribe to my channel. So look forward to talking to you in person. Today we're going to talk about design control capabilities. And when we talk about design control, matter of fact, when we talk about any kind of data management system, I like to think in terms of what is the core data management question? What are we trying to answer? And then what are the ancillary processes that contribute to that baseline data? In the case of PLM, that's really design data in the sense of mechanical design files or electrical design files. But in the case of design control and the ALM applications, what we're really talking about from a core data standpoint is the requirements. So I'm going to start with requirements. That's really the first thing. And I just wanted to mention, as we go into these kind of discussions, this is really about comparing notes. There's many different ways to do requirements decomposition, deconstruction, risk management, standards management, lots of different data frameworks that we can operate inside of. So I just want to encourage you not to worry too much about that as we move into this discussion, because this is about bringing up some data models to discuss particular problems that you might have as you go forward, some potential solutions, but don't worry too much about if your system's a little different than what I'm talking about. There are many different ways to deploy these type of systems, so don't be too concerned about it. We can talk through the pros and cons. I'm just trying to provide a framework for you to discuss it. So the first thing for us to really talk about along those lines is requirements management. We want to have a robust but not too complicated data model that puts us into a position where we can do complex design but not make it so complicated for designs that are simpler. So first thing we want to do is have that requirement structure set up, but it's the foundational data to all the rest of these systems. So let's just talk about that first, because that's probably from a deployment priority standpoint the first thing that we need to get in the system. Second thing, and maybe a 1A, 1B, is system modeling. System modeling is our formal understanding of the functional relationships in our design and where those functions exist from a systems capability perspective so that we understand clearly what we're trying to deliver. And when I talk about systems modeling, oftentimes what I'll say is systems modeling is the positive view of the design. What do we need the device to do? Whereas risk management is sort of the negative view. What do we need the device not to do? So in this first pass at trying to get a complete set of requirements, that systems modeling aspect of it is really very important so that we can establish what those requirements mean to be. And we'll talk about that in a little bit of detail here in a minute. Next thing is really standards management. How do we map in external standards to our requirements? And when I say external standards, I mean things like ISO 60601, electrical medical devices, ASTM standards, IEC standards, that kind of thing. So what is our industry view of the requirements? What would industry see as the right way to deploy any particular aspect of the design? We want to have that understanding built into the requirements as well. Verification and validation, that's really our evidence that the device complies with our definition of good as defined by the requirements. So we want to have that traceability built into the system. And finally, this risk management, what is the negative view of the design? What are the things that we don't want the design to do, and what are the mitigations we have and need to have in place to assure that those bad things don't happen? So that's really the discussion that we're going to be having over the next 4 weeks. Today, of course, is this introduction and requirements management, but we'll get to the rest of it in order as we build out the series over the next 4 weeks. Okay, so requirements management. When we do a decomposition of requirements, I think it's the 1997 guidance that the FDA put out on design control, where they talk about user needs being refined by inputs, which are then embodied in the device with some testing around it. Well, that's nice, but it doesn't really break the inputs down into their various levels. And we need to do that so that we understand clearly the difference between system requirements, which go across multiple components of the design, and design requirements, and then how those design requirements are realized in critical to quality characteristics and pushed out into production. So that's really the decomposition that we need to have in place to assure that we have all the levels that are necessary both to relate to systems modeling, but also to have all of the different aspects of what we need to do from a design deployment standpoint covered in the design control. So one of the important things to talk about here, a lot of times people look at this as a workflow. It's really not. What this is a logical decomposition so that we can explain to people who don't understand how the device works, how the device works. We want to have a very clear construction that I can talk to someone about what we expect to see out of the device and the evidence that we have that it complies. It doesn't mean that I have to do user needs before system requirements or system requirements before physical requirements. These are really aspects of a data decomposition, and it won't be uncommon for us to bring in an internal standard that plugs in some design requirements that don't have system requirements attached to them. And we'll need to run that traceability up to user needs as we develop the design, but it doesn't mean I need to do one before the other or necessarily that I have to have these in place before I start doing any design work. This is more, how do we explain what the inputs to the design are so that eventually when we get completed with the design, we'll be able to explain how the device works and then show that traceability to our evidence. So that's really what this is all about. It's not a workflow, it's really a decomposition, a logical decomposition model. We also have refinement relationships in these different artifacts. And the reason for this in user needs is because user needs are also intended uses and indications for use. Those two things are decomposed by user needs, not by system requirements. And so because of that, we need this refinement relationship between user needs of a data model. So in other words, we have a user need object that's defined in the system, and I can do a parent-child relationship with that object, the same object. So the intended uses or indications for use are defined as user needs, and then they can have children that refine them that are also user needs. Now, the reason to do this refinement relationship in these different levels is because there's n number of levels in a design like this. We don't know how many there's going to be. It really depends on the risks we've identified in the device and what level of detail we need to assure that the device complies and gives us the performance we're looking for. But from a reporting standpoint, I'd like to have one column for user needs and another column for system requirements. And if we do it in this way, we can create this flat view, despite the fact that there's relationships between the different system requirements. They're all contained in one column in a report. And that way the report doesn't get 20 levels deep, 20 columns deep. It's just user needs, system requirements, design requirements. We'll talk a little bit more about that, but we need to get a simple view of the data so that when we do reports, it's not so complicated as to be confusing to the engineers. So system requirements, we have systems and subsystems and sub-subsystems, right? Very commonly, we might have 5 different levels of system requirements or only one level. So this is also an example of where we need a parent-child relationship. The final one here is design requirements, and typically the way that goes is we have design requirements that are things like the device will include the following colors, and then a requirement that it'll include orange. And those levels of requirements are convenient and oftentimes carried in the standards, so it's kind of nice to have this ability to nest our design requirements as well. So this decomposition down to physical requirements, which are really our critical to quality characteristics, and how they're built out in the device and then developed into a set of process controls as part of the PFMEA process. All of these levels are required as mitigations to assure that something in risk management doesn't occur. So we need all these levels to have a complete view of what our mitigation strategy is. From where we're designing out problems, we have manufacturing mitigations that assure that the physical requirements are met and therefore the design requirements are met. And also we have labeling requirements, which are design requirements as well. So if we have all these levels in the decomposition, we can use those requirements as mitigations to hazardous situations. And that's where we're going to go with this. So all the levels are necessary, but I think if we don't add more levels to it, it limits how much complexity there is in this refinement relationship. So this kind of represents a full set. So I just want to say, if you don't have an ALM system currently, and you don't have this atomic view and object-oriented, data-driven view of your requirements, I would just say full stop. Your first step is to get this system in place. You could get a 2 to 3 week install, and I've seen cases where we have better than 95% reuse in the requirements alone, and that reuse pays for the system. So before you even talk about the rest of the things that I'm going to address in this presentation, I would just say that if you're operating off Word documents and Excel spreadsheets for traceability, you got to stop, get your requirements management system in place, and largely because this is the foundational data for everything else anyway, and it's going to give you a ton of value. So if you want help with that, just let me know and we'll see what we can do to get you resolved. So I'm going to just talk a little bit and introduce you to this systems modeling. The systems modeling data model in a simplistic view is capabilities which are refined by functional chains, which are refined by functions. So functions, by definition, exist in one component of the system. In a person, in a printed circuit board, in a piece of software. Once we identify an individual function, we know what component it lives in, so therefore we know what discipline is associated with it. And so when we get to that level of granularity, the function is traced directly to the design requirement. And the design requirement, we specify which development discipline is associated with that requirement type. So the function in one component of the system is delivered by a design requirement. Functional chains, however, are a set of functions that deliver a system function and are traced to a system capability. Those functional chains are across multiple components, which very often means multiple disciplines. And the system requirement is related to the functional chains in the systems modeling. These are fundamentally different things. And so one of the reasons to have a system requirement be separately defined from a design requirement is because of those two artifacts' relationship to system modeling. And the capabilities then are related to user needs. So this is really a construction that fits very nicely with our systems modeling. So what is systems modeling? Systems modeling is where we create a formal definition between the device functions so that we understand not only how are the functions related to one another, but how are they deployed in each component of the system. And so just at a top level, if you think about it as a black box, we have inflows into the functions. Those inflows are outflows of other functions, just to be clear. Those functions transform the inflows into the outflows. And so if you think about it like that, each requirement characterizes each one of the outflows. Now, the really nice thing about this, and I'm going to get into this in more detail, but the really nice thing about this is it provides us with a workflow that helps us to understand when we're done with the requirement set. So one of the things in the past that I've always had trouble with is that I'll become responsible for a subsystem. And somebody will say, I want you to write a set of requirements against this subsystem. Problem is, you sit down with a Word document, you just start writing, you don't really know when you're done. What does a fully defined device requirement set even look like? And I think one of the things that this really provides you is, if you want to know all the requirements that need to be written, you need to have at least one requirement written against each and every outflow in the systems model. If you do that, it gives you a complete characterization of all of the outflows of those functions. And once all the outflows have been characterized, you're done with your requirements, both functions and functional chains. So this really gives you a good definition of done, and it assures that your requirement set is complete. And I think that's one of the things that is really elusive in a design and something you should think about as you go forward with your requirements management system and how it relates to systems modeling. So let's just talk a few minutes about external standards management. And when we talk about external standards, I'll give you some examples. Maybe 11135, which is ethylene oxide sterilization of medical devices. Maybe 60601, electrical medical device requirements, ISO document. There's also ASTM standards for testing. There's IEC, IEEE, right? All these different agencies that have committees that sit around and decide for a particular scope of work what requirements are necessary to assure that a device gives you the performance that it needs. And so in this case, we bring the external standard into the tool and we break it down by clause. So each one of the clauses defines some aspect of how the device should be developed. Now, one of the things to consider is these external standards oftentimes step on one another. So if we have 62366, I think is medical device usability, and then I think 60601-6 is usability for medical devices that are electrical equipment. And so what ends up happening is, as you go through these external standards, the standards step on one another. So part of the question is, if I bring in, last device I did, I think we had 40 standards we had to be compliant with. If I bring in all these standards, what you're going to find is the clauses are duplicative. And If we trace those directly into the project, you're going to have all kinds of duplication in your requirement set in the device. So I'm just going to talk a little bit about how to sort of segment this work and abstract it so that you don't end up with that duplication. So what we're going to do is we're going to create a normative or company standard that defines for a product type how you're going to deploy that external standard. For example, if you have a sterilization document and the product line is syringes versus maybe pacemakers, you're going to deploy ethylene oxide sterilization differently for those. In some ways, it's the same. The external standard is going to give you that generic view, but how you're going to deploy it for this device type is likely to be different inside your company. And it's also intellectual property as to how it is that you're going to do that. One conversation I had a while back was on sterilization of pacemakers, and the way pacemakers are done is in much, much smaller chambers, at least at the company that I was discussing. Now, all of the details around how to do that versus doing pacemakers in a 7-pallet chamber, 100,000 at a time for such an expensive device, there's all kinds of reasons to do it differently. So that normative standard for sterilization of pacemakers was part of the intellectual property of how it is that that company competes in the marketplace. And so whenever you come up with a standard like that, you want to be able to reuse it for the different projects, for all the different pacemakers that you're building. And so once we have this atomic traceability from the clause to the requirement in the normative standard, what we do is we share that normative standard down to the project. And then all the requirements for that product type come with the document. And then if we want to delete some or add some new ones, we can do that as part of the project level standard. And the beautiful thing is then I have this 2-level traceability. Now, if I create a new requirement in the product requirements document, I can then share that back to the company standard or the normative library standard. And then I can deploy that new requirement across my whole portfolio, or we can leave it at the project level. Either one is fine. But when we share it to the project, we want to share it from the normative library. And the reason for that is now the traceability is defined as 3 levels deep. And now when I want to say, how is this project or this product compliant with the standard, I just have to run through 2 levels to get to the external standard. And I can scope an external standard and a project, and I can know precisely how we're compliant with that particular external standard. And also the traceability in the project will be to the test case and the test results. So I can show directly as I double click what the compliance is of any project to any standard with all the test data that's associated with it. This is something that is almost impossible to do in most companies. Most companies do this with spreadsheets in a completely manual process. So very, very powerful, high value point is management of these external standards and the traceability to the requirement set. Just to let you know, we have a program going with BSI to automatically ingest these external standards. So if you're interested in being part of that or discussing how this could be integrated into your system, feel free to drop me a line. Okay, the next one is design verification and validation. And this is to kind of give us a little bit of an introduction into some of the reporting structures that we need to have in place. So the requirements, as we discussed them before, are all traced to test cases, and the test cases have in the data model the test results that have been executed against them. And then, of course, we want this traceability from the requirement to the output, because the output is the device under test. When we run reporting, we want to know not only do we have a good test result, but what it is that was tested and the revision level of what was tested so that we can provide this sort of traceability across not only through the design inputs, but also into the outputs so that we can get the full breadth of the design control. Okay, so we'll talk about that in more detail as well. But this is a very important part of getting out of the system what we want, this evidence that we comply with our definition of good. All right, so finally, the last of these frameworks is risk management. So if we start with our requirements decomposition and we add to that our user needs, what that allows us to do then is use those requirements as the direct mitigations to problems we identify in the FMEAs. Now, I think one of the things that's a little unusual about this view is I think a lot of times when people think of FMEAs, they don't think of the FMEA as integrated into the data model. So one of the things you have to ask yourself when I'm doing an FMEA, what am I analyzing? And what you're really looking at is what is the mechanism by which a level of a requirement could fail so that I can have the next level of the requirement down as a mitigation to assure that the higher level is met. So if I have a system requirement, I analyze that system requirement for what's missing from a functional perspective, what functions are missing, what outflows are missing. That would be a characterization that would assure that that system requirement is met. And then we put the design requirements in place to make sure that we have everything in a design that's necessary to deliver the system requirement. The same thing in the physical requirement. So if we have a design requirement that is maybe something like in a sterile barrier bag, the design requirement is the sterile barrier won't migrate harmful bacteria. And some of the physical requirements might be you want to use Tyvek, or you might have a 3/8 inch bag seal. And those are critical dimensions and or characteristics of the design that are necessary to assure that that bag doesn't migrate the harmful bacteria. So in the design FMEA, we're going through from a mechanical design now because we know what component that requirement is deployed in. I can go through from a design standpoint and define everything that's required to be in the design to give me that migration remediation. And then finally, the process failure analysis takes those physical requirements, like the 3/8 inch bag seal, and then defines all the ways that that bag seal wouldn't be delivered. So you get a hair in the seal, which creates a tunnel, or we have delamination of the bag. Those different problems are associated with the manufacturing process, cleanliness of the process, or maybe the seal, how the sealing's done, the pressure of the seal, temperature of the seal. And then what ends up happening is we have a set of process controls that are necessary to assure that we get that 3/8 inch bag seal. So these FMEAs become part of the data model and explain from an occurrence standpoint how often some problem can occur to lead to a problem where the next level up isn't delivered. And so the nice thing about this is each one of those lines has an occurrence that's associated with it. So from a perspective standpoint, we can say what we believe the occurrence of some problem is going to be. And that puts us in a position where when we get the post-market data back in, we can associate it with a line in the FMEA and have a very clear understanding of what our contract with the FDA is. You know, it's not a contract, but you understand what I'm saying. If I say it's a 1 in 1,000, and I justify deployment of the device based on 1 in 1,000, and it comes in at 1 in 100, I have a problem. And that way we have context for this data coming in from the field as to how often we would expect this kind of thing to happen and when have we broken through some control limits. So this is a great way to develop that understanding and tie it directly to our trending codes in post-market. All right, so once we're done with that, what that allows us to do then is do our top level analysis where we have the hazardous situation, which is the mechanism by which a harm is exposed to a user. So this is a high level, hazardous situation is a high level question, and it's directly related to the users. So the harms carry the severity, the hazardous situation carries P1, which is the occurrence of the hazardous situation, how often does it happen? And then this risk record data element defines P2, which is how often the hazardous situation converts to the harm. And then we have a processing between P1 and P2 to say how often does the harm actually happen, what's the severity of the harm, and then we end up with a risk priority level for that particular line item, that hazardous situation harm combination. And now what we can do is we can trace that risk record to every mitigation level and explain exactly from a traceability standpoint how we're controlling the occurrence of that hazardous situation, not only from a design or a process control perspective, but from a systems perspective. And then this sterilization question I had, how often the harm is exposure of the user to a non-sterile device. There's all kinds of things that need to happen to assure that that hazardous situation where that exposure happens doesn't occur. So things from aseptic transfer techniques, storage, the sterilization process itself, all the design requirements around the design of the sterile barrier bag, for example. So all kinds of things that we need to take into account when we say that we've controlled that hazardous situation. It really needs to be a systems level view. All right, so if we want to talk about the complete picture, we have the requirement set that we had, the data model that defines the FMEAs, the systems modeling, which has our capabilities, functional chains and functions, and those are traced into the requirement set, the traceability to the test cases, the external standard clauses, so what is this industry view of the requirements, and then finally the traceability to the outputs. And I'm going to talk a little bit about why those outputs are so important. But this is really the complete picture. And I think in our next session, we're going to talk about external standards and how they're related to the broader picture of those external standards and how they're managed. But I'm just going to finish with the beginning here. what is it that we want from a reporting standpoint? Why are we even developing this design control system? I'm just going to give you one example of that, and that's the design completion report. The purpose of this is to understand what is our definition of being done with the design and how does it relate to the output's traceability. I'm going to try to answer both of those questions. So when we typically build out traceability of requirements, this is where we start. We have the requirement set and the embedded understanding of the relationship between those different levels: user needs, system, design specification, or physical requirements. Once we have that in place, that's a good start at the traceability, but it's missing all kinds of things. So the real question is then, how do we trace the test results into the report? So the next step is to say, okay, we have these test cases, and the test cases are associated with each level of the different requirements. So we have test cases for the lowest, medium, high, user needs, top level. And not only that, but we get this test result, and the test result is the last test. What is the last test that was executed against this test case? That's really what's going to show up in the traceability report, because naturally, when you do these reports, the first thing it's going to look for is the last test result that was achieved as part of a test run. So the next question is, how do we trace those outputs into the report? And so we're going to then provide a link from the output to the requirement. And of course, we're still at this last test result, but which output is it referring to? We have the part number, but we don't have the revision level. Is it the head revision, or is it just the latest revision that's associated with some DMR? Which result is the one of interest? Is it the last one? And so these reports are sort of driven left to right. We start with the user need and we provide the traceability to each one of these artifacts. And so because we're doing it that way, this is the reason we see this kind of progression and why we're seeing the artifacts that we're seeing. But I think what we really want to see is the result as it's driven from the DMR. And so if we do that then, and we specify the DMR, which is really a precise SKU, and we say, okay, what are the revision levels of each one of the objects that are part of that bill of materials? In this case, we might have this kind of a revision set that's associated with the DMR. Well, it's going to be a different revision set than what is the current revision set. And not only that, if we say, what is the test result that's related to the revision of the DMR that's shown, what is the last test result that's associated with that revision of the output, we get a very different result. And in this case, what we're doing is we're driving this report right to left, not left to right. We're starting with the DMR and then we're going into the test management. So in this case, we have two revisions. They're both the same revision and we have a good test result. Okay, we're good. We have a green that says that we have the test result we expected. But here we have in the purple a test case that doesn't have an output associated with it. Or on the bottom, we have no test case and we have a part, but it hasn't been tested. So in this case, we really have an unassociated relationship where we need to come in and define what it is exactly that's going to be done. So in this case, what we have is an unassociated level where we have a test case that doesn't have an output and we need to add that output, or we have an output that doesn't have a test case, so it hasn't been tested. So in this case, we have to go through and create that association so that we can test it and get the result that we're looking for. The next one is really test our down rev. So we have a revision of the DMR that's a newer revision than the last revision that was tested. So we don't have a result for some current version of the output. So that's a problem as well. We have to get those two revisions the same. And then finally, maybe the revisions are the same and we get a bad output. So what we'd really like to do is get to a report that shows the relationships between all these things. And now we understand, is the current DMR aligned with the test result or not? Not only that, from a workflow standpoint, how many have passed, how many are down rev, how many have failed? And once we get all to green, we should get this resolved check mark that says all of the outputs that are associated with this device have been tested against their commensurate requirements, and we have a good test result. So this is just a super important reporting structure because it really talks to how do we need to associate these different artifacts together to get the result that we want in the reporting that is so difficult to get. Last time I did this, just to go through my traceability took me a week and a half. But to get this report, I had 6 inches of paper on a 40-part assembly to justify the differences and how to get to a current understanding of what the DMR needs to be based on the test results that I had. This is a very time-consuming process, and having automated reporting would greatly accelerate the back end of preparing a design for production. So just want to kind of give you a sense of where are we heading with all this and why do we go through all this effort. It's really to get reports like this that greatly reduce the amount of labor that's required to provide the traceability. And in addition to that, it actually gives us a correct result, which is very difficult to do when we're building it all manually. So that being the case, we have our major design control capabilities: requirements management, systems modeling, standards management, VMV, and risk management. And next week actually is going to be systems modeling. We're going to talk about systems modeling, not standards management. We'll get to standards management a little later. So really appreciate your time and attention. This is, again, my contact information. I greatly value having a personal one-on-one conversation. We can talk about comparing notes and what it is exactly you're doing and whether or not I can help in that process. So thanks for listening today and look forward to further discussions in the future.